All right, this is Coach Jay, aka the Awesome Elf, with you, and we are about ready to begin. Here's where we left off. We're going to go into section 6.2b and 6.2a a little bit on that as well. Okay. Now, I think we also did this at the top that we'll just kind of review and kind of go over. We talked about how if we combine the January and December months, we would have the variables x plus y, or the two random variables of x and the random variables of y, right? We talked about that. And we said that if we had 0, 3, these are the different combinations that we could have. We would have a total value of 3. 0 and 4 would be 4. 1 and 3 would be 4. We could have multiple ones, right? We talked over that. We said 1 and 4 was 5. We did this, right? I think we did. Okay. This was 5, this was 6, 6, and 7. Okay. We also then said that at 0, 3, there were two probabilities, right? And when we combined them, what would we do with those two probabilities? We multiplied them, right? And I don't know if we filled this out completely, but I would just fill it out with your notes real quick. And I would, again, if I see, I would get those notes out and just throw these down. This is important on this part, okay? So we would get 0.18 for the first one. If we kept multiplying, though, we would get I want to make sure I got this right. 0.24. I know we know how to multiply, so I'm just throwing these down. 0.16, 0.12, 0.08, 0.06, and on 7, we did 0.04. Now, before we get to the predicted, I'm going to actually X these off because I'm going to come back to these and kind of show you what's happening within this. But I need someone just really quickly to throw these in their calculator really fast, and I just need us to kind of put that on there, okay? So have someone just put that down. Now, it seems like I'm going to hop to the second section, and I kind of am a little bit. But what I'm going to do is this. I'm going to take, instead of x plus y, those random variables, and add them together. This time on the second one, before I kind of figure these out, which we'll come back to, I'm going to do x minus y, okay? Meaning this, what is the difference in the number of pieces sold between January and December, okay? If you believe I'm an elf, there should be quite a bit of difference, because after December, it doesn't matter how much I make, right? So we would say in this, the January one would be 0, and the December one would be 3, okay? Mary Mark?
What are all those points?
Yeah, good question. And this is I'm pulling it back from here. So this right here would be like at the top part.
Oh, so you're just writing what you're combining.
Correct. Those in parentheses are just the ones that you're combining there. Does that help?
Yes.
So that'd be like 0, 3, that'd be 3,
Got it.
1 and 3. So if I did a 1 and 3, that would be 4, and I would take 0.4 and multiply that 0.6.
Yeah.
Okay? Do y'all see how I did that there? Is there anyone that doesn't see that? I may not have hit this yesterday, so remind me. Ella, we good?
Wait, which part of the note?
This one right here,
Yes.
I believe it is right above this one. I think the way I clipped it, it might be right there towards the end. Am I wrong on that?
No, you're right. You're
Am I
right.
good? Okay. So are we good? Everyone's good on this? How I created the probability distribution, right? Okay. Did anyone find the mean, variance, and standard deviation of this?
Yes.
4.5.
Perfect.
Good job.
1.12.
Is this the variance?
Yeah.
Perfect. And standard deviation?
1.06.
1.06. Now, here's what I want you to look at, okay? We'll come to the second one here in just a second, okay? All right, this is kind of like the aha right here. Like you got to really, really get this. So I want eyes right here, okay? 4.5 is the mean, right?
Yes.
As we go backwards, we recognize that we added x and we added y. So when we add both two random variables of random variable x and random variable of y, what did we do with the means as well? You also add. So if I add the two random variables with the mean, we just simply add them, right? Now with the variance, what did we do with the variance? What happened there? Well, what did we get? We got 1.12, right? Okay? We just added them, right? So just like we did with mean, variance was the same exact way. Now here's where the rubber meets the road. This is like, please focus up here on this one, because this is the part that will be on your quiz today. Okay? What did we do with standard deviation?
No comment.
Oh, say this again, Matthew.
Square
Square what?
the numbers.
Okay. You
Square
square
and
the
then add
numbers,
them.
and then you did what?
Yeah.
You add them together. Now watch this here. Here we go. Let me get a different color. This is the like, oh my goodness, big part, like golden nugget for the lesson right here. One, I want you to go like this. Okay? This is our gang sign. Okay? Don't say that outside of the school, please. Okay?
Coaches are teaching side.
Alright? Someone's gonna graffiti this. I don't need in huge trouble, alright, Matthew? Alright, I want you to say, one cannot simply add standard deviations.
One cannot simply add.
You're in the club, you're in the gang now, okay? One cannot simply add standard deviations, okay? Alright, now listen,
We're all pledged.
if I add x and y, both random variables, you can add mean, you can add variance, just like you would normally do. Same thing. But one cannot simply add what? Standard deviations. So how do you find standard deviations?
We just add the variance and then
Glad you asked.
square root it.
Ooh, I could possibly do that. Well, let's look at that. What we're going to do is this, okay? We're going to, the formula for this is as follows. The standard deviation squared of, we'll just say, we'll call this right here
A,
t. Right here, t is x plus y, right? Is equal to the standard deviation squared of x plus the standard deviation squared of y. You say, Coach, what the heck is going on? Come back with me for just a second,
Just
okay?
square them both and add them.
If I square the standard deviation, what am I getting?
0.7.
If I square standard deviation, what am I getting? Variance, right? So if I get my standard deviation and square it, I get 0.89 and 0.239. Would you agree with that?
Yeah.
Okay, so watch this. We're going to go backwards
Square
here.
variance.
So that means right here, for x was 0.839. Am I right with that? Was that right? I think I went backwards. Let me backtrack. For the x would be 0.89, okay? And 0.239 would be the y. So
That's the top one.
0.23 is my x, and 0.89. Did I flip-flop those? I think I did. But either way, regardless, one is one is the other, right? Now, how do I find then the standard deviation of t? Well, what can I do with this?
Add them
Just
together.
add them together, right? And when I add them together, what did I just find?
The standard.
The variance.
The variance. Got me? Okay? All right, are you with me?
Yeah, negative square.
This is the tough, this is a little tough part, I get it. How do I go from variance then, because that's what this is, to standard deviation? I square root it, and guess what I would get? 1.1, 1.06.
And when do you have to do that?
Yeah,
Like,
when do
is
you-
there a way?
Great
that we
question.
know?
The only time I do this, right, is when we have two random variables that are either added or subtracted together.
Only added or subtracted.
Only
Uh,
added or subtracted together.
Isn't that what we did for that?
You can, but there are some multiple choice questions, as you'll find, where they'll say, hey, two random variables, right? Here are their standard deviations. They won't give you all of this stuff up here like you see. And they'll have to say, hey, if I added these together, what would be the resultant standard deviation in mean, right? So mean and variance we add together, right? But right here we go. One cannot simply add standard deviations. Got me?
One can
Alright.
simply add.
One can not simply add standard deviations. So that's how I get here. Does that make sense? All right, here we go. Let's go one more. Okay, one more, and then we're gonna bring it together because Jerry needs a break and we need to do an activity or something, right? All right, let's do this. This time, just one more because now you kind of get it. It's gonna be a little quicker here. We're gonna take x and subtract y. What happens now? Okay. So this time we just take 0. These are the different possibilities. 0 minus 3 is -3 with the same probability. Okay. -4, same probability, 0.12. 1 minus 3 is -2, same probability, which is 0.24. Okay, are y'all getting this here? -3, which would be 0.16. 2 minus 3, which would be -1, which is 0.12. 2 minus 4 is -2, and that would be 0.08. Y'all getting this down? 0, I appreciate the honesty. 0.06,
I said no, I don't understand.
and -1 is 0.04. Okay?
I feel bad.
All right, Matthew, you don't understand this?
Yeah.
Because you're not the only one. I appreciate your honesty. I really do. Okay? All right, let's backtrack for a second. Do you understand what's in orange up here? Do you see how I set that up? all I did was, now I'm giving you two scenarios. I'm saying, what if I combine months January and December, right? What would happen? This is what we would get right here. What is the probability of getting a 5 or a 6, right? A total of what I produce in terms of woodworking, right? Projects. That's this up here. Now this is a little different. What is the difference in the number of pieces sold between January and December, right? In that case, what am I doing? I'm taking what I did in December, subtracting it from January to get what I have here, right? So all this means, the negative ones mean that's how many I sold more of in December than January, right? Okay, during my busy time of the year or whatever, okay? So this is how I set this up. So look at this. This has the same probability down below. Follow me? Okay? Now, once I set this up, we call this what, Matthew? Do you remember? This chart or whatever? A probability distribution, right? Nice, because that's how we, probability and then a distribution. Good. So now, based on this, we're going to look into it. That's what we're going to look into. Ella?
Why the probability is the same?
Great question, because even if I went back here, right, and I look and say, what is the difference between January and December? If I took 0 and subtracted 3, got me? What is the probability of getting 0, like when I say 0 minus 3, it's this and this, which is still 0.18. Does that make sense? So I still have to multiply those because it's like this and this together, right? Does that help you? And they're independent, so we just multiply them together, all right? In fact, you wouldn't be able to do this if it wasn't independent, all right? That's just a side note. Now, as we look at this, what am I going to do with the means if I subtracted them?
Subtract.
We're going to subtract the means. Good. Now, I could plug this in. Who plugged this in before? Couple of y'all did? Morgan, would you mind just changing the top? You should have this one already, right?
Yeah, it's
We won't predict them.
the
We'll just put them here.
the mean is negative 2.26,
Thank you. And what was the variance?
1.23,
Good.
and standard deviation is
1.11.
1.11.
Awesome. Thank you so much.
So they tell us, the calculator tells us the standard deviation.
Say that again.
Calculator tells us the standard deviation if we put it in, right?
Correct. Here's what I would say be careful of, all right? All eyes up here, because this is literally, I'm wrapping this up, okay? And I want to be careful because I want to make sure I'm helping you for the quiz, okay? When you get here, on the quiz, you will not get a probability distribution today, okay? What will you get? Well, let's talk over that. I'm going to give you the means of both x and y, got me? And the standard deviation for both x and y. And I'm going to say, if I combine the random variables of x and y, what would change in my mean and what would change in my standard deviation, okay? That's what I want to make sure. I'm telling you right now because I want to be extremely fair with you,
So
okay?
your mean,
All right.
you would just add them together for the mean.
Add or subtract depending what it was, right?
And for your standard deviation, you square them both and then add them together and then square root them.
Perfect, okay? Do you want me to show that on this real quick? Okay? So what we would do to find this number, this is what we're finding, okay? Y'all follow me? We're finding this. I'm showing you how did I get to this, other than a calculator, okay? We then go, all we're going to do is go backwards and say, okay, let's go to this right here. This is my standard deviation of 0.943, right? That's the x, standard deviation of x. The standard deviation of y is 0.49. The formula, remember, one does not simply add standard deviations, right? So I take 0.943, okay, and I square it. Got me? I square the x. And when I square it, what am I really doing? Ella, do you know what I'm doing when I square a standard deviation? Good, I'm getting a variance, right? Okay, it's really what we're doing. You can see that here, but again, I'm just showing you how I got the work shown here. Plus, I take 0.49, which is the y. I square that standard deviation, right? Which is, again, the variance. When I do that, on the top I get 0.89. On the bottom, or the y part, I get 0.239, right? And when I add both of those together, I get basically a combined variance, right? That's what I'm doing. Correct. You said that perfectly. You said it better than I could, Max. It's exactly right. So when I add this together, I would get 1.13. Is that right? I think that's right. 1.2. We rounded to 1.12. And then once we find that combined value there, we finish it off by taking the square root of it right here. Okay? Square root of it to get to standard deviation. Matter?
Yeah, is it gonna be the same?
That was one for addition.
Say that
That
again.
was one for addition though, right?
Yeah, what do we do for subtraction?
Yeah,
Let's
when we
subtract them.
Yeah, what are you doing?
Should be the same, right?
Yeah, we got different.
What's the square root of 1.12?
1.06.
1.06, right? Isn't that what we put down here?
No.
No,
So we're talking about the subtraction. We're talking about the subtraction.
Yeah, this should be the same. Did we not get the same there?
Yeah, boy.
Should be 1.06 is what I have down here.
Please, please don't make this. Not today.
Is that what you got, Gabby? 1.06? I think it might have been maybe I plugged it in wrong or when someone plugged it in wrong, a number wrong. But whether you add or subtract, this formula that I put on the side is the same.
Oh, it's the same.
So the variance
Same.
will be the same.
Same thing. You don't like subtract.
Correct. Do not, it should be 1.06. So look right here. These right here are the same.
It's the variance.
Correct?
So the
No
variance
matter
The
if
variance
you
should be
add
the
them
same.
Variance should be variance might be,
But you
no, it should be the same too. That's right. Variance should be the same too. Did I find? Yes,
And why is the mean?
that's correct.
How do you get?
Now, what is the only thing that changes?
The main.
The mean did, right? Because the mean, when it's added, we just add them together. When they're subtracted, we subtract them together. Okay? But the standard deviation, we still take them, take the standard deviation, square them, add them together, take the square root of it, whether we add the two variables or subtract them. Okay? All right, are we good? Does that make sense? All right, we are going to do this, go through it. Oh yes, this was someone in the other class asked if when I was the Hobbit and the Lord of the Rings if I got a picture of this and they failed my class, so they're out of it now. But this is actually a picture, and again, one just think of that. One does not simply add standard deviations, right? They actually did that. He did that for me. I got a picture of it signed in my room. It's good. All right. So finally, here's the thing. I think this might help you. So what happens? We add 2. This is like our final cap on it. All right, are we good? Let's do this. Eyes right here. Listen with your eyes. This is the last thing, last little bit. What do we do when we add in terms of variables? What do we do with the mean? Well, we simply take the means and add them together. Good. The mean of x plus the mean of y, right? When we subtract, what do we do with the means?
Subtract them.
Mean of x minus mean of y, right? Morgan, did you figure out, did we get that?
Yeah,
finally?
we had that. We had -2 with 0.06 and 0 with 0.08, but there's so like our table.
Gotcha. I'm glad we caught that. I'm glad we caught that there. It's good. Again, this is the variance because it's standard deviation squared. So we know that in either of these cases, we take it to find what the standard deviation is. We take the squared of x, which is again variance, plus the squared standard deviation of y, right? And if we were going to find that, we would do one final step by taking its square root, right? What would happen if we subtract them? Same thing, yeah. Exact same thing. Good. Same thing. Whether we add or subtract those random variables there. Okay, Emily?
If it's asking for the variance.
Hold on just a sec, Max. Go ahead, Emily.
For subtraction, are we always use x to subtract y, or is that matter? Like, how are we subtracting it?
Great question. It does not matter in terms of this formula, correct?
From the mean.
For the mean,
Yeah.
it would, because if I did y minus x,
Yeah.
then it would just be like a regular subtraction problem. I would take the mean of y and then subtract it by the x. Does that make sense? Because I did x minus y here,
Yeah.
that's why I did the mean of x minus the mean of y. Does that help you?
Yes.
That's a great question. Great question. Max?
If it's asking for variance, you wouldn't ask for it, right?
Correct.
So
And
that's asking for variance right there.
Correct, this is. And so what I was saying is if I went and took it a step further and found standard deviation, the only difference on that is I would square root both sides. Okay? So remember, variance is easy. We just add them every single time, right? And then we're good to go. Only other note is this. This won't work unless it's what? It's got to be independent. In, added, or subtracted. That will work too, Morgan. That'd be good, okay? It's gotta be independent, okay? Questions? All right, here's what we're gonna do, okay? Just to kind of solidify this, we're gonna do a little group thing together, okay? And let me kind of show this up here for you. And this will launch us into the quiz, okay? So this is, again, preparation for the quiz.